So we do first draw the triangle, and then label 3 points ABC.
Yeah.
And then label AB 4, label AC 3, then label ABC 44. So AC. This is where I have to use the formula half B sine C.
You're thinking of area. This is for an unknown angle.
Will this be sine rule?
Yeah.
So will this be sine 44 over 3 equals to sine x over 4. And then times, and then do I just need to do sine minus 1 of 4 times sine 44 over 3?
Yeah.
And so that be 67.9.
And it says 2 possible values. Any idea how you get the other one?
Would we somehow find what A is and then do 180 minus 44 minus whatever A is?
It's for sine. The second answer is always 180 minus the first. So 180 minus what we just found.
So 112.1.
112.1 degrees.
Yeah.
And that's it. 112 and 67.9. So sine, the second answer is always, so first answer is always arc sine, and then second answer is always 180 minus first answer. Any questions there? Okay. If you like, we can do, yeah, we better do one more. Okay, how about this one?
So wow. So I'm guessing I need to find, first of all, find the top angle of the triangle on the left. To somehow find x. I'm not really sure.
Yeah. So how would you find that angle?
Would that be sine 40 over 60 equals to sine, I don't know, whatever, over 80? And then just find out what x is from there. Wait, so I can actually put into my calculator that equation and it'll give me the answer.
Yeah. I'm going to do it the same. I think that with maybe sine, we'll see how it goes. So it seems like it worked out all right.
And so now we've got that angle.
So where is that angle?
Is that the angle opposite A2?
Yes. Oh wait, is it the angle opposite 80?
Or is it the angle at the top?
So do you mean like this angle?
Yeah.
So what do you notice about the size of this angle?
It won't be that because it's obtuse.
Yes, and so what's happening here, this is the ambiguous case. What the calculator gave us was the if you look at this whole triangle, it always gives you the one close to 0, so it gave us that there.
Right.
And so that angle there is 58.987. Any idea what this angle is?
Will that be what? Will that be 58.987 as well?
Yeah.
And then to find out x, would we just do 180 minus 58.987 minus 58.987?
Yeah. And I want to do something different. Tell me what you get for that one.
I got 62.03.
Let's just say 62.0 degrees. 62. Write down one modeling assumption you have made.
Do I need to write an equation here or something? Or
no, I'm not quite sure. The assumption is that the ball swings symmetrically. Okay, so I didn't realize that was an assumption. But yeah, basically, if the ball swings symmetrically, and so these two are the same as each other, these two angles are the same. Like it's the same line.
Yeah.
You know, wrecking balls at the bottom of both of them, and it's just swinging back and forth. What was I going to say? Yes. So you know how this angle was also the 58.987?
Yeah.
It's on a straight line with this angle, and so this one would be 180 minus the first answer, and so that's why that's where it comes from. 180 minus the first answer gives you the second one. It's because they're on a straight line together. And so you could see in the total triangle, the acute angle is all the way over here. So 80 is opposite that one. But then if you were just looking at this triangle with the obtuse angle, to get that you have to do 180 minus. And so that's why that happens.
Yep.
Any questions about that?
No, I don't think so.
Okay, so that's the ambiguous case, it's called. This is a half AB sine C. Okay, how do you find the area of this triangle?
Is this where I have to do half AB sine C?
Yeah.
So half times 4.2 times 6.9 times sine 75.
Yeah. And that gets you 14.0. Okay, how about this one?
I'm just doing this. Yeah. So if you just draw it and then label the points. And then if you write half A, B, sine C,
Mm-hmm.
so half times 5 times 6 times 6 times sine X equals to 12.
Mm-hmm.
And then sine X is equals to... Oh, wait, can I just put this in my calculator?
Yep. And if there's ever a problem with the calculator, just you can always do it manually.
Yeah. It says that X is 53.1.
0.1 degrees. That's weird. This is the ambiguous case, but how are we supposed to know that? AC is the longest side. Not 5, that's 6. If AC is the longest side, does that mean that... So what is 180 minus 53.1?
127 point... Oh no, 126.9.
And so that's roughly 127. I'm just trying to see, how could we know that? You know, B is the largest angle because AC is the largest side. Okay, I suppose. So if it's opposite the largest side, then it must be the largest angle. And for it to be the largest angle, it couldn't be 50 something, because then they wouldn't add up to 180.
Yeah.
All right, have to watch out for that. I never thought about that. Let's see this one. I think that's fine. Let's just do part A, I suppose.
So if you draw it, draw the triangle.
I think that's the triangle they drew.
All right. And then find the length of BC. So would I need to find out the angle of ACB?
I don't think so.
If I just do sine 52 over 16.4 equals to sine 75 over x, will that give me the answer?
Yep. And try that in your calculator.
Yeah.
So this is an unknown side. Oops.
I got x is 20.1.
Centimeters. Looks about right. This one's 16.4. And then finding the area. All right, how would you find area?
So will that just be half AB sine C?
Mm-hmm.
So will that be a half times 16.4 times 20.1 times... Oh, and then I need to do 180 minus 75 minus 52, don't I?
Yeah.
And so, yeah.
that is. 180 minus that, 105. Take away 50, 55. Take away 2. I think it's 53. And then you get the answer from there. Grant. Any questions about that?
No.
That's all right. So I just wanted to try this one really just for the unknown side. And yeah, you made your life difficult by putting the unknown on the bottom. But it's all the same to your calculator. Because you did it with your calculator, it made no difference. It's all the same. Okay, this looks pretty good. Let's try this one.
Okay, so we have to draw a triangle again, don't we?
Yeah, I'll give this a go.
So, so would I like write out the area here or something? And then that would be half x plus 2 times 5 minus x times sine 30. And then would I expand the brackets here? So that would give me half minus x squared plus 7x. Oh no, yeah. Oh no, sorry. Oh no. That'll be plus 3x. Sorry. Plus 10 times sine 30. Will I just do sine 30 times a half?
Yep.
And then that will give me a quarter.
That's it. And so it's a quarter, and then just make it look like their one.
Yeah.
I think that's more than enough. How about B?
Okay, so now I have to complete the square here.
Do you know any other method for finding the maximum?
My calculator.
Yeah, how would that work?
So I'd literally just put it into the graphical calculator and then just press the maximum bit.
Could. What would you get if you expand the bracket?
2.5 plus 3/4 x minus a quarter x squared. Oh, right.
Yeah, and so you could always use your simple calculator for that one to get the maximum.
Yeah.
Might be a bit more comfortable. Yeah. And or we can use graphical or whatever. 4. And so that gives us x is 5, x2 is minus 2, doesn't matter. Press equals again. The maximum, x equals 3 over 2, y equals 49 over 16.
Do you know how to do that with the graphical calculator?
Sorry?
Do you know how to find the maximum with the graphical calculator?
Yeah. Did you put in the graph thing for it?
Oh no, I just put into the simultaneous thing, no, the polynomial thing. Sorry.
That's a good point. Does it tell you the maximum in that mode with that one? Maybe it doesn't. Equation. Polynomial. Degree 2. Let me just go with what I already have there. Now, so with the simpler calculator, the polynomial also gives you the maximum. With the graphical, it looks like you'd have to actually do a graph for it.
Yeah.
Or you can always use differentiation and make it equal to 0.
Yeah.
Yeah. Any questions there?
No.
Or you could always just complete the square, but
Yeah.
that's tricky. You could use differentiation to find the maximum. Yep. Or you could use calculator. Let's see this one. I like the look of it. Hang on. That's very similar. Is this worth doing, or you think you'd be okay?
Probably just give it a go. I think it's just A or something like that.
Okay.
Yeah. So PRX plus 3, QR6 minus X. Sine PRQ equals to 2/5.
Mm-hmm.
So does that mean I need to put in? Does that mean I need to do sine minus 1 to the 2/5?
You could. However, your area formula. What is the area formula?
Half AB sine C.
Yeah, and so they already give it to you in the form of sine C.
Yeah. So do I just find the area here?
Mm-hmm.
So half times 6 minus X plus 3. Times 2/5.
Yeah. Then you just make it look like that, basically.
Yeah. So I got 1/5 times 6 minus X times X plus 3.
Mm-hmm.
And then those brackets expanded, that'll be minus X squared plus 3X.
No.
Minus 3X.
Yeah.
Plus 6X. Plus 18. And then do I just need to do do I then just need to do minus X squared plus 3X plus 18 over 5?
Yeah. That's it. And B.
So do I just literally put that equation in and then just find the maximum?
Yeah. Do you want to try it, or?
Yeah. So So I got max is 3/2 and 81/20.
Yes, 3/2 is same as 1.5, and then that one is 4.05. And so, yeah, so instead of x and y, they wrote it as x and area. Okay, any questions there?
No.
Hold on. Let's see. This looks very similar.
I think we probably could just go to the next one. I think.
Yeah, that's very similar. And then this one. Very similar. Am I right?
Yeah.
Yeah. And this is easier because you're just doing it in terms of x, so you just solve for x with the calculator. Is this worth doing, or you think it'll be okay?
I think I'll probably be okay.
Yeah, it's just sine rule, and then you do the area afterwards. That one.
Probably a tick.
Okay, solving triangle problems. Yeah, just in general. Do we take a look? Yeah, you're fine. Okay, how about this?
Okay. Okay. Okay, so do I need to split this triangle up? No, this quadrilateral up in half here.
And vertically or horizontally?
Vertically.
Okay.
And so angle DBC will be. I don't know if I even need this. I'll just put it in. It's 50.
That'll be what, sorry?
50.
How'd you know?
Because 180 minus 75 minus 55. I'm sorry, I don't know. I put 75 in. It should be 55. Sorry. 55. Sorry. So I think DVC is 55 degrees.
I don't think we can say that we've cut 140 in half exactly.
Okay.
Looks like it's more this way. And
Okay.
any other ideas?
Do I need to find the length of DV?
Not sure. This one says A is the minimum distance from D.
So does that mean that A is equals to 70? A to D is 70.
I believe so.
So, and then um,
How could you find the length from the length of DB?
um, you could do cosine rule.
Mm-hmm.
So was that like a squared plus b squared minus c squared over 2bc?
That's for an unknown angle.
So I have to rearrange it.
Yeah. So it's usually like that.
And then I have to square root that whole thing, don't I?
Yeah.
So would it be the square root of 75 squared plus 80 squared minus 2 times 80 times 75
Mm-hmm.
times cos 55,
Mm-hmm.
and then I've got 71.7
Let's say 5 sig fig.
71.708.
It's okay.
Oh, is that a right angle triangle or no?
Which one?
No, it won't be. On the one on the left that we cut up.
What makes you think it's right angled?
No, it won't be.
Could be, I don't know. Let's see, the angle from B to A to D, the area enclosed by the 4, but we have two sides. I'm looking at this one. So that one, 71.708. So they did the sine rule. Yes. Now that you have that, you can do the sine rule.
So, all right, yeah. So will that be sine 55 over 71.708 is equals to sine x over 75.
Yep.
Um, I got the answer 66 degrees.
And any more? Higher degree of actually?
Yeah, it says like 66.05.
Let's say one more.
Sorry, then it would be 66.046.
Yeah, 5 sig fig. 66.046. Okay.
And then the missing angle in the triangle, is that what I need to find out now?
You could.
And so that will be 42.246.
Okay. What else?
Um, so this is A from B. Do I really don't know what I have to do.
How about this angle?
Yep. So right, so 180 minus 66.046.
It's not 180.
Sorry, 140,
Yeah.
and so that'll be 73.954.
Any idea how you can use that to get the length AB?
Could you do sine rule?
No. This is two sides and the angle between.
Oh, cosine.
Yeah.
So is that again just a squared equals to b squared plus c squared minus 2bc equals it?
Yeah.
So will that just be a is equals to square root of 70 squared plus 71.708 squared
Mm-hmm.
Minus 2 times 70 times 71.708 times cos 73.954, and I got the answer of 85.225.
So that's 85.3
Yeah.
because it's the final thing. And we
It'll probably be 85.3.2. Sorry, it'll be 85.2. Sorry.
okay, 85.2. That's meters, and if we could keep it to 81. Where did we go? 71.708. Then it's saying what angle was that? B DC. They're saying that's 58.9. We said that was 66. Did we just round or something? Sine rule. Sine B D C over 75 is equal to sine B C D. So that's the 55 thing. Yep. I don't know. Either you wrote it down wrong, or they did, or they just rounded it.
Uh-huh.
I don't know. We used the exact same method, so maybe I don't know. Anyway, what was I gonna say? Yes. There's no obvious way to go about it. You just kind of keep filling in the blanks. The angle BAD, that would just be more of filling in the blanks like sine rule. How could you get the area? Total area.
BAD. Oh no, sorry. Of the four masts, is that just by finding by getting the area from the two triangles, then adding them together?
Yeah. And so it's always two sides and angle between. So like the ones you just used, those two with the angle between a half AB sine C plus, and then I would go with the ones that they gave you in the question, because you know they're definitely going to be right. A half AB sine C for those ones. And just add them together. Any questions about that one?
No.
Okay, that's weird about the number. Either it's book or just rounding. And their one was the same thing. Yeah, get the two areas, add them together. Let's see. I think we did. Is that question in the right place? Find the two possible. Oh, okay. Hang on. Yeah. How would you go about this one?
So yeah, you just label it. So would I have to treat theta like it's x?
Yeah.
So do I just need to do half AB sine C equals to 48 here?
Yeah, and you'll get an answer for that one. It says find two possible values. Oh, hang on. So that's the sine. Oh, okay. Yeah, let's do this one.
And then if I find out what theta is, so it says theta is 53.13.1301.
Let's say 130.
And then do I just need to do cos of that?
Yeah.
And so it says the answer is 3/5.
Great. I like that. How do we get second answer?
Is that just by doing like 180 minus 3/5?
180 minus is for sine.
Pardon?
180 minus is for sine.
Right.
You could press up and retrieve the answer if you have it. Or you could do inverse cos 3/5 to get it back again.
So yeah, so I've got that answer here again, and then what am I supposed to do?
We want the second answer, and so it is 180 minus the first one.
Right. So it says the answer is 126.9.
And so cos theta
will be minus 3/5.
Great. Let me see though. My guess. Okay. This is a triangle, so it's not going to have a negative angle. For theta, you do. Sorry, for cosine, you do 360 minus. So it's not for cosine. It's not 180 minus. It's 360 minus. And so, do 360 minus original theta. Or there's a few different ways of doing it.
So sorry, am I doing B now?
No, this answer isn't like it's correct, but it's pure maths because an angle can't have a negative
Oh, right.
size. And
So it won't be that, basically.
so for sine, second answer is 180 minus first. For cosine, it's 360 minus first. So 360 minus theta.
So will that just be 360 minus 126.92?
Minus the 53 one,
Right.
I believe.
I got 306.9.
And so what's the cosine of that?
3/5.
Is it minus 3/5? Is that the answer? Yeah, it's plus or minus 3/5. Okay. But clearly, All right, silly thing. Question B. Given that AC is the longest side, find the exact length of AC. How would you find the length of AC?
Cos rule.
Yeah, I think you'd be fine for that. Am I right?
Yeah.
And the cos of theta is just 3/5 or minus 3/5. And they'll both give you the same thing, 53.130 degrees. Actually, yeah, that's why it could be plus or minus, because they'll both give it the positive one.
Yeah.
Okay. Any questions there?
No.
Okay. Find the area of the triangle. It's just more of this stuff. Is this worth doing? You want to do it? It's up to you.
Probably just gone something else, I think.
Yeah. You love these triangle things and you're very good at them. I think it's because we did it in GCSE and we did all the exam questions for GCSE, so it's very similar. Yeah, this stuff. Solving triangle problems.
Okay.
So here's solving trig. Oh no, this is just graphs. Yeah. Sketch the graph. Calculator. Sketch the graph. Calculator, sketch. Use your graph. Let's see if we make sense of this part B1. Given that cos 45 is that, use your graph to find all the solutions to this one. I think I would use cos theta. So that's whenever what x coordinates have a y coordinate of 1 over root 2. I think I'd probably just use you're solving equations for that. So this one should be good. Sketch. So just calculator. Sketch, calculator. I'm waiting for them to have an algebraic one. No, those are all calculator. They might look weird, tan of minus x, but that's just calculator. Okay, this is the stuff that is not, you can't use your calculator for. What is part B? Do you know?
So is that a function?
Yeah, y equals cos 2x. So y equals cos x becomes y equals 2 cos x. What transformation is that?
Is that all y coordinates multiplying?
It is next to the x.
So I'm guessing that means all x coordinates multiplying.
Yeah.
Yeah.
Do you know? So it's x direction. Do you know what the name of the transformation is if it's multiplying?
No.
That is a stretch.
Right.
So if the numbers are multiplied by something, then it's a stretch. Multiply or divide. X direction, what scale factor?
What's the scale factor? Sorry.
The scale factor of the transformation.
Yeah.
Do you know it?
Is it just times 2?
It is times a half. So this is you did this a little bit in GCSE. It looked a bit different, but it's this exact same idea. With the x's, it's always the reverse. With the y's, it's the same because they already moved it to the other side. So if you had a quadratic x minus 3, x plus 7 or something equals 0, what are the solutions?
X squared.
No. X equals
X equals 3, X equals to minus 7.
3, or x equals minus 7. And then we do a transformation. X becomes 2x. And so what's the new solution?
1.5.
Yep. Or
minus 7.
Sorry.
Minus 3.5.
Yes. So it's a transformation. X is replaced with 2x. What happens to the x answers?
So they become 2x minus 3.
Sure. What happened to the final answers?
They divided by 2.
Yeah. And so when x becomes 2x, you're not timesing the x coordinates by 2, you're timesing them by half. They're divided by 2 because you have to bring that to the other side.
Okay.
Yeah, this one never gets easy. So you might not remember this stuff. Any idea about part B?
So will that just mean that the x coordinates are going down by 20?
It's the same idea. It's always the opposite.
So x coordinates are going up by 20.
Yeah. And so you would write that. The y coordinates aren't affected. So you write that as the vector 20, 0. So positive 20 in the x direction, nothing in the y. Do you remember the name of the transformation when it's plus or minus? Must be an added or subtracted to it.
No.
That is a translation.
Right. Yeah.
So maybe we'll just go over these sometimes. So translation by vector 20, 0. Have a crack at this one. Y equals cos x becomes y equals cos x plus 30.
So does that mean that it will become the x coordinates are going down by 30?
Mm-hmm.
And it's translation.
Hold on. So that's translation. And do you remember how you write this bit?
Minus 30, 0 is the vector.
Hold on. Yeah. Some of that's a stretch. It's the same idea. So maybe that's just something to look at. Okay, so that was the last thing in that chapter. Okay, let me just skip back. Why did you want to do triangles?
Pardon?
Why did you want to do triangles?
And it was just the next thing after sine rule and cosine rule.
You're very good at these. You don't need to be doing this stuff. You could try it if you wanted, but I know you'd be good at it. Sine rule, I think you're very good at it. This thing, the triangle could look like this. So the 80 has two angles that are opposite it. One is an acute angle down here, one is an obtuse angle down here. And that's why the sine of that thing, like theta, is arc sine of that. And then you do 180 minus because they're on the same line.
Yeah.
And that's where that comes from. That's called the ambiguous case. Just to watch out for that. Area, you're good. Yeah, let the calculator do the work there. That's good. This one, pretty good. You can use calculator for maximum, or you can differentiate, or you can complete square. You did it with the calculator. That was pretty good. Let's see, triangle problems. Again, I think you're pretty good for this one. Just keep filling in the blanks. Like any blank you can fill in, any side, any angle. Like I was trying to find a quick way to do it, and if you look at the answer, they didn't do it any quicker.
Yeah.
You know. Let's see. This one, this one, this one. Alright, it was just plus or minus, and we did it with sine. 180 minus. Yep. Those ones are going to be similar. Again, there's probably like some work to do with them, but I think, you know, you just keep filling in the blanks. Eventually you get there. You look for a cosine rule, you look for sine rule. If they mention area, you use area. All that stuff you can calculator to sketch it. Transformations, maybe we need to go over. In the x direction it's the opposite, in the y direction it's the same, because they've already brought it over. Maybe transformations we